In this video, we are going to continue covering the topic of Bluetooth beacons. In the previous video, which you could find here, we covered the iBeacon standard, and in this one we are going to focus on the other popular standard, the Eddystone beacon standard. Hi, Mohammad here from NovelBits, and on this channel, I help developers and engineers learn all about Bluetooth Low Energy and how to develop for this technology. We already covered what beacons are in the previous video, but just to recap, Bluetooth beacons are simply Bluetooth Low Energy devices that mostly operate in the transmit-only mode, broadcasting data for other BLE devices to discover them. After Apple released the iBeacon standard back in 2013, Google followed suit with their Eddystone standard in 2015. Now, unfortunately, both Eddystone and iBeacon have not changed much or improved since their releases. In fact, the Eddystone project repo was even recently archived on GitHub. Nevertheless, they both have remained pretty popular due to the fact that they provide a sort of reference or standard for Bluetooth beacons. iBeacon is also a special case for iOS since it's the only way on iOS to be able to reliably and continuously monitor BLE devices in the background. Here's what the Eddystone format looks like. Now, if you recall, advertising packets are formatted in length type value tuples. So in this case, the packet includes the following advertising data types. First is flags, second, a complete list of 16-bit UUIDs, and third, the service data for a 16-bit UUID. So similar to iBeacon, the flags field in Eddystone is also set to enable the BR, EDR not supported, and general discoverable bits. The complete list of 16-bit UUIDs includes the Eddystone UUID, which is the hexadecimal value FEAA, shown here in little endian format, which reverses the bytes. And the service data includes a length field, which depends on the frame type included in the packet, the type, which is 16 hex, and 16-bit Eddystone UUID, the FEAA, little endian format here as well, and finally the actual data, which could be one of the following frames. First, we have the Eddystone UID, which is used to broadcast a unique 16-byte beacon ID composed of a 10-byte namespace and a 6-byte instance. Second, we have the Eddystone URL frame, which is used to broadcast a URL using a compressed encoding format in order to fit more within the limited advertising packet. Third, we have the Eddystone TLM, which is used to broadcast telemetry data. This data includes battery voltage level readings, temperature readings, advertising count, and time since power on. Now, this could be encrypted or unencrypted. And finally, we have the Eddystone EID, which is used to broadcast an encrypted ephemeral identifier that changes periodically at a rate determined during the initial registration with a third-party web service. As you can see, the Eddystone standard, just like iBeacon, really just defines the format of the data included in the advertising packets. So now let's go ahead and implement this on the Silicon Labs BG22 Explorer Kit, which is a $10 development kit provided by Silicon Labs, and we'll be discovering the Eddystone beacon device from the Silicon Labs EFR Connect mobile app on Android. To do this, we first have to download and install Simplicity Studio, which is the official IDE from Silicon Labs for working with their chipsets and development kits. So once we have Simplicity Studio launched up and running, we will start with the launcher perspective. So make sure you have the BG22 Explorer Kit connected to your computer and launch Simplicity Studio and go to the launcher perspective. This is where it goes by default. In here, make sure you have the selected board to match the BG22, the one that's connected, and hit start. So what we're going to do is going to start with the SoC empty example, which is available from within Simplicity Studio. So in here, go to example projects and demos, and we can just search for empty. And we're going to start with this Bluetooth SoC empty example. And in here, I'm just going to change the name. So I'm going to call this Eddystone. Sometimes this doesn't update correctly, so just make sure that it does. Once this is created, it'll give us access to a project. It'll create a project for us with all the source code to just run a very simple example with really bare bones in this case. So the SOC empty doesn't have anything. It does include a GAT database, which means it also allows connections, but we won't get into that for this example because the Eddystone does not rely on connections and rather it uses the Bluetooth low energy advertisements. So in here, what we're going to do is go to app.c. So app.c is the main file that you'll be working with and implementing and adding code for your application. So this is what gets called by the stack itself. So in here, you'll find multiple functions. We have app init, which you can put your init code in for when to get called upon startup. You also have a process action. This is the infinity or the while loop that basically gets called every time or continuously throughout, and it will, if you want to handle something that happens continuously in your application, you would place it here. Then you have the BLE or Bluetooth SLBT on event. This is the Bluetooth low energy event handler that gets called from the stack, and you have multiple different IDs for what you need to handle or what you would like to handle. So we can even go into here and take a look at the different IDs. These are all defined in here in this SLBT API, or we can go to the website docs.scilab.com to find those. So the first thing we want to do is to add logging and be able to print out message logs and see those from the device. So what we need to do here is go back to the launcher, or actually SLCP. So you go to the project, the SLCP file, double click it, go to software components and wait for it a second until it loads. And then we are looking for a couple of components to install. The first one is USART. Let's wait for that to load up, and once it loads up, we will do a search for USART, install that, and then the IO stream, and then we install the log component. Okay, so USART, if you scroll down all the way down to IO stream, you'll see there's an IO stream USART. We can just keep the instance name as it is. Once that's installed, we can now look for log and scroll up all the way to the top here, and you'll find application utility log and install that. So the other thing that we need to install as well is, or set, is the advertising sets. So basically for this example, what we're going to do is send out two advertising sets, one for TLM and one for UID. So in order to do that, we need to set something called the advertising set, or the number of advertising sets allowed. And if you just do search for advertising, you'll find something in the link layer, features with commands and events, and advertising base feature. Go ahead and configure that. And then in here, this sets the maximum number of advertising sets reserved for a user. And so we're going to increase that to 2 and just close that out. I'm going to go back to app.c and just add a simple log message. And I'm going to do that in this boot event. So app log info, and then we'll just say Eddystone example started. Okay, now let's go ahead and build. Make sure it builds with no errors. And that built fine, so I'm going to go ahead and debug. And it should hit the breakpoint in main at SL system init. Once I hit start, I can go and check that the Eddystone example started. Log message, if I just restart it here just to make sure there were no other log messages displayed, and we can see it here. So now we have a way to at least display some log messages in our application. And let's go ahead and change the device here from connectable scannable to non-connectable, because we're just advertising Eddystone advertising packets. So we're just going to do scannable non-connectable. or actually non-connectable. We don't need scannable either. So let's go ahead and do that. I'm going to just change it here. There is another spot other than the at boot up is when the connection is closed. Obviously, we're not going to handle that anyways because we have no connection. So we can just delete this whole part. Okay, so let's just make sure it builds. I'm going to go back to Simplicity IDE perspective and build the project. Okay, so the project built fine, and now let's go ahead and start implementing. So what we want to do is go to the top of this file, and right here we're going to set a couple of handles for the advertising sets. So basically we're going to advertise two advertising sets, one for UID and one for TLM. So in here you're going to have two sets of these, or two sets of advertising. Each one has flags, complete list of 16-bit UIDs, service data, and then the service data itself is going to be different based on the type. So we have a couple of them here. We have UID, which is 20 bytes of data, and it's defined in the Eddystone specification online, and the TLM, and then specifically we'll be using the unencrypted TLM, and that will be defined in here as well. So let's go ahead and define these. So we'll just modify this handle to be specific to UID, and then we're going to copy paste it and set a new one to TLM. So that's for that. And now what we want to do is actually define the advertising data. Okay, so we're going to define a struct. And in this case, I'm going to define one struct for both the TLM and UID. I'm just going to call it Eddystone data, and that's a type. And in here, again, if we go back to that diagram here, you see the first thing is flags, starts with length, type, and value, and we have 1 byte for each. So I'm just going to go ahead and do flags, length, and then another byte for flags, type, and finally flags, value. Okay. Next one is 16-bit UID, and I'm just going to copy paste my code. And for this, again, there's a length, type, and then 2 bytes for the UID, and we're going to have to reverse that again from FEAA is the original one. We're just going to write it in there as AAFE because it should be in reversed or little endian format. The next one, I'm going to have service data. So again, for the service data, we have also length, type, and then before the actual data, we have length, type, and then we have a UID, and that's here. And then after that, I'm going to use this trick in C, which is a union. So since each frame is different in terms of the number of bytes, the UID and the TLM, the two that we're going to use in this case, and we're going to be alternating between them so that the device sends both of these. If you go to the specification for the TLM, it talks about this, and it's basically about interleaving this frame within a UID frame. So that's what we're going to do. For this one, what we're going to have to do is we'll just go ahead and set a union type, and in here I'm going to go ahead and define 2 types. So we have one for the UID and one for the TLM. Again, the UID in here, you can find that the UID is 0 to 19, so it's 20 bytes. That's what we're going to store in it. And then we have 0 to 13 for the TLM, unencrypted TLM, so we have 14 bytes. So that defines the value. Now we can go ahead and actually define a static const for each of them. So this is going to be of type Eddystone type data T, and the first one I'm going to call it advertise data underscore UID, and then I'm going to go ahead and define what's in it. let's define the other one just so we have that, and then we'll go ahead and start adding the data. So this is advertised data and then TLM. Okay, so for these, I'm not going to waste your time, so I'm going to go ahead and copy paste what I have and I'll go through it. So for the UID, this is what I have. Basically, we're going through each of these struct elements and fields and setting them. So again, you can refer to the specification and you'll see that based on the definition, we have flags is set to 02, 01, 06 for the type and all that. So in here, as you can see, 02, 01, 06 in hex, and then we have 16-bit UID list. This is 0303 and then AAFE, 0303 AAFE, and then we have length and type and UID, 16-bit UID, and then service data. So let's talk about the length here. Basically, for UID, it's going to be 20 plus 2, that's 22, plus 1, 23. So it doesn't include the length. So the length is going to be 23, which is 17 in hex for UID data. And this is what this is. And then for the TLM, it's going to be 14 plus 3, which is 17. So it'll be 11 hex. Okay, so let's go ahead and talk about the elements within here. So these are based on the specification. So if you go back to the specification, you can see that for UID, we have a frame type 00, that's always set. We have ranging data. This is calibrated TX power at 0 meters. I just set it to 0, so that's the second one. And then we have 10-byte namespace. Again, this is big endian, and you can see that note here that all these multi-byte values are big endian. So in here, it's going to, we just set it to an arbitrary number from 01 to 0A. So that's 10 bytes. And then we have 6 bytes for the namespace or the instance ID. And then the last two are 0000. So that's what you see here. So the next one in the TLM is going to be very similar, except that the service data frame is going to look different. So everything here is the same in the beginning. The third one, the service data, has a length of 11 in hex. So that's 17 decimal. And the type is the same. It's 16 hex. And then AAFE, just like we saw it. And then we go back to the spec for the TLM packet and we see that the frame type should be 20. So the first byte is 20 instead of 00. We have a version. This is set to 00. And then we have a voltage, battery voltage, 1 millivolt per bit, which means it's going to be 1 millivolt for each decimal. So in here, I set it to 100, which is 64 hex. So it should show up as 0.1 volts, so 100 millivolts. The next thing is a beacon temperature. And there is a calculator where I calculated and I just put in an arbitrary value of, I believe, 72.5, which I meant in Fahrenheit. And that's what I used as the beacon temperature. This uses some format called 8.8 fixed point notation, which uses a floating point or as a way to represent floating points in bytes. And it is also signed. So in here, this is set to 72.5 Fahrenheit. And the last thing we have is advertising count and time since power on. And for those, I just set it to 01 and 02. So that's all we need to do for defining the advertising data. Now let's go ahead and use the advertising data. So again, we changed the handle for this from the default. So this will be UID. And then we're just going to copy and paste it and do the same thing for TLM. So again, just going to copy paste this to create a new advertiser set, just a different handle. And then for here, I'm just going to replace this with TLM. And that should be it. So let's go ahead and build and just make sure that our application compiles with no issues. And then I'm going to start the mobile app. So we have a couple of warnings. Looks like we have some data that's defined and not used. Okay, we still need to do something. I forgot about this. We need to set the data because it's the original application actually does the generate data. So it generates automatic data. Instead, we are going to set data based on the advertising data that we set up at the top. So for here, for the UID, we're going to also set the advertising data, not the scan response data. And then we pass it the advertised data UID, which is what we set up here. And for the next one, for the other one, we use the advertised data TLM. So we can use the same function call, and instead of generating the advertising data, we are going to set it. And for this one, we have to do TLM. So it's always really a good idea to look at warnings because sometimes that points out real issues in your code and not just things that you should ignore or you could ignore. So again, now we have 0 errors, 0 warnings. I did forget to set one thing here, and when I copy pasted that code for setting the data, let's just delete this comment. UID, this one has to be TLM. So this compiles correctly, but it's incorrect, and at runtime we'll probably have issues. So let's go ahead and fix that. And here I'm going to launch the mobile app now, and it built okay with no issues. Okay, now we're ready to debug, and here I have the mobile app as well. So let me debug the application, and when it hits the breakpoint, I'm going to refresh the scanner here, so I make sure that I'm waiting for the device to show up. So I'm going to do a resume, and now it shows up. And in here, as you can see, there's Eddystone data, and it alternates between that and TLM. So once it captures the TLM packet, I just make sure we're still scanning. And now if we look at the data, you can see the Eddystone data is showing now, and now it switches to TLM, and then it switches to Eddystone, and then it goes back to TLM. And you can see that the version shows as 0, voltage 0.1 volts, just like we expected. Again, the temperature, I set it to be 72.5 centigrade, and then we have, or Celsius, and then we have advertising count is set to 1 when it captures the TLM, and the uptime is 0 for the days, for the seconds as well. Now keep in mind that the counter for the time since boot up that we included, and in here we hard-coded it to 2. This is a 0.1 second resolution counter, so 2 would correspond to 0.2 seconds. So it was really just a dummy value that we included. And so the mobile app only shows up down to resolution of seconds of actual integer seconds. So that's why we only saw 0 seconds on the mobile app when we looked at this. So that's it really for just building an Eddystone. Again, it's pretty simple. You really have to just worry about the advertising data format and how that's set for your device, and that's pretty much it. Now, obviously for TLM, what you'd want to do in your own application when building a product that's based on this is to include actual telemetry data such as the voltage reading and the temperature, and then having timers for the uptime or using some RTC, as well as the advertising count, keeping a counter for that and using that in the advertising packet instead of just setting hard-coded values. And that's it for this video. If you've enjoyed watching this video, then hit the like button and the subscribe button to be notified of new videos when they come out. Thank you for watching, and I'll see you guys in the next one.